Just to recap, um, okay. So I sent you this article uh, about kind of the latest on standard model and inflationary theory, and the standard model also involves cold dark matter, an acceptance of cold dark matter, which I don't know what I think about cold dark matter. I don't know what the hell it is. They don't know what the hell it is either. So I'm just like, what? Yeah, I understand physicists have to come up with things, and just like, well, there must be something that's doing it, all right? That has these I don't know. They don't even know what properties it would have, really, I guess they know. They're trying to find it. They haven't detected it. I'm not sure it's there. Okay. I didn't mean to put this editorial comment in this while I was talking to you about it, but I can't help it. I would love just to give you, say, here's everything that happened up till now. Well, first, the Earth cooled, and then the dinosaurs came, but they got too big and fat, and they turned to oil. And then the Arabs came, and they bought Mercedes-Benzes, and then Prince Charles started wearing Olive Lady Dinah's clothes. Which is my favorite recap. I'd love to just do that for you, but unfortunately I have to keep interjecting how I think a lot of it's full of shit. But anyway, the article is very good, and it pictures a nice diagram of their kind of the structure of the universe. Their sort of non-Euclidean perception of what the universe is shaped like, and it's a fucking nutty shape. You would think the universe, a Big Bang, would just result in something that looked like a firecracker, with the event horizon being the outer perimeter of the firecracker, and that has all kinds of properties which I won't go into. If the universe is shaped like that, it has, the way I think it's shaped, then I should be able to ask questions that a physicist could answer me and say, no, we discovered this, that, and the other. Just kind of not say, okay, I'll accept that it's not shaped like that. But one would think that's what it would be shaped like. But nope, it's shaped like a burrito. It is. It's shaped like a Taco Bell burrito, actually, if you look at the diagram. Anyway, you can read it, all about cold dark matter and Kobe, and and what we're learning from that, and they're looking for some of this stuff in some of these big hadron colliders and linear accelerators, so I don't know. We'll see what that turns up. I'm not sure. I think it might fail. I don't think they're going to find the Higgs particle. I'm not sure it's there. I have to read up more on it. I have to brush up on particle physics. Particle physics is a whole fucking thing. And I think I need to talk to a particle physicist, because that's the first problem I'm having. Like I told you about all these particles. Why so many? I thought everything was related to light. You could just use light. That was pure energy, and that energy, could decay into other things. You split out and you get a neutrino and anti-neutrino. So I'm not sure why everything just wasn't light. Why it was all this other crap, which I think can also sort of emit photons or whatever. So, yeah, so you can read that, and I am going to try to remember when the hell I started talking. I think it was 11:08. Sorry, it's too bad this thing doesn't have a clock or a timer on it. So I'm trying to figure out what nothing is, and there's two states of nothing that we talked about. One was, or there's not two states of nothing, but there's the lowest, form of zero energy, like you said, zero energy. Or did you say the lowest? You said the lowest. So I guess you could go negative. I think you did say lowest, but for some reason I was thinking you said zero energy. But zero energy is just the vacuum of space. It's absolute zero. And then of course we have this sort of negative pressure thing, which I don't know if it corresponds to what can be called negative energy. I thought negative energy was something else related to gravity or something. I don't know. I don't know how they're talking about this stuff right now, because I don't think they really are. Anyway, oh no, I'm sorry, they are. They're talking about vacuum energy. They're talking about vacuum energy and how maybe that's driving the inflation of the universe. That theory, I think it's just a hypothesis, right? I'm not sure it's a theory. I think they're still working on it, but I think that's what I think. I think the vacuum energy is driving the universe, and that the vacuum energy is going to account for a lot of the missing mass and other problems. We don't know. We can't figure out how to measure the vacuum energy, or we can't detect it. And I've been thinking about that for a while. How to do that? Because you have to back up your theory with any experiments that can be verified. So I have to come up with one to detect the vacuum energy, and I don't know what that is. It sounds again like the Michelson-Morley thing all over again. What's our speed through the ether? So when do I have? Oh, I can go to 18, I guess. I have 6 more minutes. I'm gonna assume. We'll see. So you can get. So how do you get to the false vacuum? You get to the false vacuum by shrinking something down. So in order to have nothing, you have to have the false vacuum. If you want to define the false vacuum as nothing, I'm not sure that it is nothing. Nothing to me, I think, still seems like it would just be a vacuum. I think that, nothing is, it's just empty space. But is empty space anything? But the fabric of nothing to me, it would encompass all of being, essentially. It's like, or all, if nothing dominates, we were, I don't know, I don't see it, it's somehow outside of us and around us and something. I just thinking about how, what nothing is, and I still think it's something. Nothing. Is it something? I've been doing a lot of quotes that's my second quote from Bloomcounty. Today in the news, nothing happened. There was no news. Later, a special report. Getting to the bottom of this lack of news. Nothing. Is it something? Yeah, I think nothing is something. I think it's the vacuum. Zero energy. That's nothing. Because the false vacuum has a huge potential behind it, and it just that it spawns the universe. It can't help it. That's what it does. So, if nothing is a false vacuum, then the universe is being spawned constantly. Or it's spawn. I don't know. If a false vacuum exists, and there's always a false vacuum. If a false vacuum, is always somewhere around, and there's this universe being spawned all the time by it. But their idea is that it's in its own space. What the hell does that mean? So that's fucking weird too. Idea. To me, it's like, well, if there's one giant vacuum, then I guess you could have a thermodynamic miracle where, 10 to the 41st particle and antiparticle sort of quantity of energy is just sort of unleashed. That seems to me hard to believe too. I guess in the vacuum of space you can emit particles and antiparticles, and I think it's observed often. But how often is it observed where two sets of antiparticles come out of the same place? Because that has to happen. You have to have this. Because the Big Bang is based on this idea that this shit all happens simultaneously. You can't. I suppose you could have a piece of vacuum of space that was just accumulating particle-antiparticle pairs for a while. But the problem is the Big Bang theory is predicated on this sort of self-annihilating particles. In particular, the annihilation of the monopoles, which is how inflationary theory was discovered. Right? There's no monopoles. There should be. But I have to stop talking, and I'm going to upload this and I'll record another one. I'll just continue with my rambling.